This is my all-time favorite method. This is the washer method. So what's going on here is we're going to take basically distance between two functions and revolve that around the x or the y-axis or some other axis, as you'll see in the next section. So you can see what's going on is we have this volume, and then within it we're going to remove some of that volume from it. If you want to take a look at this video, really good video, kind of show you how it revolves around, and that'll be a good one for the visual. So the main idea to this is just like I was saying earlier, we're going to find the total volume of this figure, the greater figure here, that would be the greater function, the top one, and remove the inner volume. So our formula is going to be pi, and then we're going to use capital R squared minus little r squared. And then dx, that's if you're going around the x-axis. Obviously, if it's around the y-axis, then you're going to use dy. So the main thing here is realize this is the outer radius. And this is the inner radius. I really want you guys to realize this is not going to be the integral of capital R minus little r squared. This is not that. Do not use that. Do not use this. What this is doing is you're going to find the difference in the radius and then spin it. No, what you want to do is you want to find the volume of the bigger figure, which would be our outer radius, and then you'll take away the volume of the little figure. So once again, you would find the volume of this outer radius, that would be this giant volume here. Find that entire volume by doing the pi r squared on it, and then remove the little volume. So that's what's going on here. We have the bigger volume, the outer radius's volume, and then remove by subtracting the inner volume radius. So we'll do the squared on the outer function minus the squared on the inner function. So let's go ahead and take a look at this first example. So region R is enclosed by y equals x and the curve y equals x squared. What's the volume if we revolve this around the x-axis? So revolving around the x-axis, and the reason why I picked these examples, I want you to see we're not going around the y-axis. If you're going around the y-axis, the outer would be the pink graph here, y equals x squared, and the inner would be the blue graph because the blue one's closer to the y-axis, this one's further. But we're going around the x-axis, so what's further from the x-axis would be the blue graph. So that would be our outer radius. So the blue one would be our outer, and the pink one here would be our inner radius. So our integral, we're going to integrate pi from a to b, and we're doing it in respect to the x-axis, so from 0 to 1. Now we're going to do the outer first, so that's going to be the x minus the inner. Doing that in respect to x. It wants you to evaluate, so I'm just going to go ahead and take this a couple steps, and that's it. So this is going to equal pi times, I would split up the integral. I forgot my dx. I always seem to do that. And so that'd be pi times 1 cubed over 3 minus pi times 0 cubed over 3 minus pi, pi times 1 to the 5th over 5 minus pi times 0 to the 5th over 5. And so then that would be pi over 3 minus pi over 5. And I'm this far, I might as well just finish it, which would be 5 pi over 15 minus 3 pi over 15, which is 2 pi over 15. And there you have it. That would be the volume of the figure if you were to take this region R and revolve it around.